Really?
Is that okay?
Hi, kids. We were talking about strong versus weak acids and bases.
I don't think either of us are acids and bases, but I'm strong, you're weak.
Whatever.
It's okay.
All right, let's talk about the difference between strong and weak acids and bases. So because we're talking about acids and bases, we're talking about dissociation or separation into ions. Okay, strong acids and bases completely dissociate, so 100% separate into ions. Weak, incomplete dissociation into ions, so less than 100%. And Mr. Rev is taking forever to write.
And wait, just to be clear, when you say dissociation, maybe I missed that. What do you mean by dissociation?
Separate into ions.
Separate into ions.
Something like hydrochloric acid is HCl. It will completely separate into H plus and Cl minus.
So there's nothing that doesn't separate.
Right, completely separates.
Okay, so I've got the definitions. Do we just have a couple of examples that we can do here?
So strong hydrochloric acid.
So let's see, our acids would be things like HCl,
HBr, nitric acid,
HNO3,
things like that.
There are far fewer strong acids than there are weak acids, just by the way.
There's only 7.
There's only 7 strong acids. We gave you 3 of them right there. Well, what about bases?
Bases are things like sodium hydroxide, potassium hydroxide, the ones with hydroxide.
The hydroxides, basically. Okay. Let me change my color. Let's make it fun. So what about acids that are weak?
So we have things like acetic acid, which is vinegar.
Okay.
Carbonic acid, which is actually in soda, because the carbon dioxide in water makes carbonic acid.
Okay. And what about some bases?
Bases, things like ammonia.
You're like really testing my formula writing and
what about baking soda?
Baking soda.
Sodium bicarbonate.
Mm-hmm.
You got
it. I know it. I'm good. So that's pretty much it, right?
Yep, just complete dissociation versus incomplete dissociation.
Awesome.